the last chapter, it was quadrant trig, and it was for picking a pair of points in any of the quadrants, right? And we dropped a vertical line down, or vertical line down to the x-axis. And we got our trig functions from it. So any angle, we could do any angle between 0 to infinity, both positive and negative. We could always get the 6 trigonometric functions. Now in this chapter, if you notice at the beginning, it says acute angles and the right triangles. So on page 49, it is right triangle trig. And so you're going to only be able to get angles that are acute, which means between 0, greater than 0, less than 90 degrees. So that's the limitation of right triangle trig. But the relationship between this trigonometry and the last trigonometry was when we did quadrant trig. If we picked let's just arbitrarily pick a point over here in this quadrant, and I'm going to pick this one. There were two things that we did. We took from here out to that point, and we said that that was called little r, right? And r was going to be the square root of x squared plus y squared, where it was in this particular point, x is a minus, what did I do, minus 4. Y is 2. And then in describing it for you, they said to drop a perpendicular down to this axis. So technically, what we have developed is a reference triangle, right triangle right here. But what we were talking about is we were talking about what is the trig functions for this angle, and we had you know, positive and negatives in terms of our sine and cosine because of that, right? Now, all our sine and cosine and tangent are all going to be positive in right triangle trig, and we are in essence doing only the first quadrant. If you look at it from the last chapter, right triangle trig for acute angles would be first quadrant trigonometry. Does that make sense? This theta will, if you move this thing back into this quadrant here, and we pick, if we pick that point right there, which is going to correspond to x is 4, y is 2, and we run a ray out, then this r right here is going to have the same absolute value because it's always the positive. And then when you drop your reference angle, oh, I want to go, got it. And then the angle we're dealing with is this angle. And when it's an acute angle, right triangle trig, it's only angles in this quadrant in terms of the last chapter's discussion, right? So right triangle trig, you're limiting yourself to only angles in this quadrant in terms of quadrant trigonometry. You follow what I'm talking about? Because it's acute angles, and this is a right angle in this quadrant. So you can't get angles above 90 or less than 0. You cannot talk about any other quadrants but the first quadrant. So that's a big limitation. and then you're always going to be talking about it in terms of right angles. And then remember the sine was going to be y over r, this side over that side, that hypotenuse, and cosine was x over r. Now look at page 50. We're going to be dealing with this right triangle, and what are they saying? The sine is this is the reference angle, is going to be what? Opposite side over hypotenuse, because this is a right triangle, correct? I'm waiting for you to tell me yes, James, with your head. Yes or no for you. Are you good? Okay, let's look with what we know about sine. Sine in terms of this one, of this angle right here, was y over r, right? All right? Okay. Now, in terms of this angle, this side is opposite side. Okay, I can't think of opposite. This is the side opposite that angle. This is the hypotenuse. And this is the adjacent side. They will say side adjacent, but I'll just refer to it adjacent. This is side opposite. And it's the side opposite the angle, the side adjacent the angle, and this is hypotenuse of the right triangle. And notice that the y is what in terms of words? Side opposite, right? Side opposite the angle. And then the r is the hypotenuse. So when we're talking right triangle trig, if we just look at any old right triangle, so I'm just going to draw a right triangle. And in that particular thing, then if I draw this like this, that means it's a right triangle, right? And notice that in this previous one, this was the right angle right there. And that was the acute angle. So what way we're going to define this is that there's actually two acute angles in the right triangle, right? There's this one, and then there's this one. Correct? So if I call this one theta, and I'm going to call this one alpha, then in terms of the sine of theta, is it's the side opposite and the hypotenuse. So it would be this side over that one, right? Now, well, let me go ahead and letter these. I might revise this angle the way I do the notation. I'm going to call this, in terms of a point, this is always called C. This would be called A, and this is B. Now, usually we say A, and the small letter A is the angle at A. If this is B, this theta is actually small letter B. No, I'm going to withhold that. I'll retract that statement. What we normally do is this. The side opposite A is A, and the side opposite B is B, and the side opposite C is small letter C. And the angle here is normally called A. So this would be called A, and this would be called B, and this would be called C. So our theta is actually sine of B, right? The angle at B. And the side opposite is what? Small b. So it's opposite over hypotenuse. So that one is B over C. And the cosine of the angle B is adjacent side over hypotenuse. And for this one, it's going to be small letter a over C. Now, let's just go back here and look. You see, if we say the sine, it was always what? Y over R. Y is the opposite side. R was the hypotenuse. Cosine was what? X over R, adjacent side over hypotenuse. If you look at this as a right triangle. So that's the relationship between the two. But on a right triangle, we can never get any acute angle greater than 90 or less than 0. Because this right triangle, you can go all the way up to just under 90 degrees. If you want to, you could say I could go to 89 degrees, then this angle up here is 1, right? And then this is 90. And the interior angles of the triangle are 180. So if this is 90, these two have to be acute angles, less than 90 degrees, because they have to sum to 90. Now tangent for B, remember that when we talked about it, we said it was y over r. Well, for this one, it's going to be opposite over adjacent. So if we take the letters, it's B over A. Are you following me? Now, let's look at angle B. If we do sine of B is going to be opposite over hypotenuse, and the opposite is A, right? Sine of it is A over C. And then the cosine of B is adjacent over hypotenuse. And the adjacent side to A is what? This B. I probably should, I'm getting too much involved. Cosine is adjacent over hypotenuse. And the adjacent is B, hypotenuse is C. And then the tangent at B is opposite over adjacent. and that's A over B. A, if I do the sine, it's got to be opposite over hypotenuse, right? Oh, I was supposed to be doing A. Thanks. Yeah, no. See, I'm doing this angle up here, right? And the opposite over hypotenuse, just like that.
Does it matter when you start this one, A or B?
No, won't make any difference. It's always going to be opposite over hypotenuse.
C is always the 90.
C is always the 90-degree angle.
But your A and B are still
Yeah,
interchangeable.
yeah. Now, notice this, that if you take the sine of A is equal to what? Cosine of B. Now, sine and cosine are cofunctions. And what's the relationship between angle A and angle B? They're complements. They're complements, aren't they? The sum of the two of those two angles are 90. So what you can do is you can say the sine of B, which is equal to the sine of B is B over C, is equal to the cosine of A, and A plus B equals 90 degrees, right? So A is equal to 90 minus B. So this is equal to the cosine of 90 minus B. The sine of an angle is equal to the cofunction of its complement. Sine and cosine are cofunctions. Remember we talked about cofunctions? So yeah, the sine, if you take the sine of whatever angle you got, it's going to equal the cofunction or cosine of its complementary angle. And the cofunctions of each other are sine and cosine, cosine and sine, and tangent and cotangent, secant and cosecant. Those are cofunctions of each other. So let's just look at 50 and see. They're on that page. It's telling you in right triangle trig how you always define the relationship. The sine is going to be, and if you go, sine is, rather than saying side opposite, you usually say opposite over hypotenuse. So let's just redraw it. Yeah. Yep. Yep. So you can pick any angle. We'll pick this angle right here, and we'll say that for just the sake of is A. Then always the side opposite the angle at A is always small a. Opposite the C is small c, and the side opposite the capital B is this. So if I do the sine of A, you always say it's opposite over hypotenuse. So what's the ratio going to be? A over C. The cosine of this is what? adjacent over hypotenuse. So it's B over C. The tangent is going to be what? Opposite over adjacent, A over B.
Easier when you call it, but
Yeah, but you see that? Now let's go to B. The sine of B is going to be what? Opposite over hypotenuse. So it's going to be B over C. The cosine at B is going to be adjacent over hypotenuse, A over C. The tangent is going to be opposite over adjacent, B over A. And these are the only two acute angles for which the trigonometric functions work, and it's in a right triangle. And those acute angles can only be angles, they can't be 0, but it's just greater than 0. Can't be 90 degrees, it's got to be just less than 90. Okay? And the relationships are there. Now, you look at sine and cosecant are related as what? Cosecant is 1 over sine. It's not the cofunction. It's a, so if what you're doing is the sine and cosecant, the cosecant at, say, for example, A is going to be 1 over the sine of A. So if the sine of A is A over C, the cosecant of A is what? C over A, inverted, right? And then these, you just use your identities to figure these things out. The secant at A is 1 over the cosine. So if you want to, all you have to do is learn sine, cosine, and tangent. Because if I want to know what this is and I forget it, I say, well, the cosine of A is going to be what? B over C. Therefore, the secant has got to be what? The inverse of B over C. So you just go C over B, right?
So the whole purpose of the ABC is to say it's part of one right triangle only.
Yeah, this right triangle trig, all I'm showing is the relationship between right triangle trig and what we did in the first chapter. And it's actually only allowing you to do first quadrant. Yeah.
That's why you use an ABC, so you know.
Yeah.
Right triangle.
Yeah. Yeah. And then usually when you're doing right triangle trig, you always use the words, don't use A, B, and C. Always use sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. If you learn those 4 and then know that sine is 1, you know, the cosecant is 1 over the sine, then you can figure it out. I guess I'm saying don't try to remember, you know, that it's hypotenuse over opposite, because you know then it'll be just too confusing. I think if you just learn sine, cosine, and tangent in terms of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, then look at the identities. If you have to do secant, cosecant, cotangent, and you just flip them. You just have to know which one's related to which. And the difficult thing is what? The one that seems strange is that cosecant's 1 over sine, and secant's 1 over cosine. But don't mix up those things with the cofunction identities, which are on page 51. And all that, the cofunction identity says that if you take the sine of A, which is A over C, its complementary angle is B, and so its cofunction, which is cosine, cosine of B is A over C. They're the same thing. So what's the cofunction of sine? Cosine. What's the cofunction of cosine? Sine, right? What's the cofunction of tangent? Cotangent. What's the cofunction of secant? Cosecant. And when you do cofunctions, what you have is if you have a function of an angle, it's equal to the cofunction of its complementary angle. And that's got the complement's always gotten by subtracting your angle from 90. And see, that's what they're showing you right there. So, and we use this thing along with those identities in the last chapter. Technically, all you have to know for angles is you have to know the sine of the angle, the cosine of the angle. You don't have to know the tangent, because you can use the relationship. The tangent is by identity is sine over cosine, right? Remember from the last chapter? And you know that the secant is what? 1 over the cosine. And the cosecant is equal to 1 over sine. So once you know these two values, you can calculate everything else by the identities. You see that? So and right triangle trig is used extensively in in surveying with similar triangles, because what you do is you turn angles, and if you in right triangle trig, usually what you're doing is you're doing some object. You're saying this object is so high, you're making the assumption that you're at a right angle here, and then you measure a distance out here. And if you're measuring a tree, you don't know the height of the tree, what you do is you turn the angle from here up. Undo it. And that's going to give you in a similar triangle a ratio, right? And you can do the ratio of sine, cosine, tangent, and cotangent. So in any triangle that has this angle, the ratio of this side to this side to that side, and that side to that side are all going to be the same, right? So if whatever the degrees are here, if you want, all you have to do is measure this distance. And if you want to know that height, which would you do? Would you do a relationship of sine, cosine, tangent, or cotangent? Or you see, if you did the tangent, you'd get the ratio of these two sides, right? Opposite over hypotenuse. And you'd know this angle, you'd know this side. You could calculate this side by saying this unknown, which is opposite side, is to the adjacent side as the tangent of the angle. And that ratio stays the same, right? That's just a ratio of a similar triangle that has that angle. So this will be an unknown value. This will be a known. So you have 25 feet of length there. And this will be some angle that you will turn with your instrument, right? And that will say the common ratio of these two for that angle will be something like, I don't know what it'll be, but let's just say it's 10. Then x is going to equal 10 times 25. And you can say the height of that tree is 250 feet. Because any angle, no matter where you draw it, the ratio of that side to that side is always going to be a common ratio with this. And that's how you're going to use it in surveying, or if you're drawing graphs on a curve, on a piece of paper, drawing things out. That's how you use it. Now there are certain trigonometric values that are specials. And notice that they're saying that these are the special values. 60 degrees, 45 degrees, 30 degrees. And actually there's going to be 90 degrees and 0 degrees. But we don't talk about these two right now. We talk about those. And if you notice that there's sine of the angle and cosine of the angle. Now, because tangent is going to be what? Sine over cosine? Once you know these two, you can calculate that, right? Well, the sine of 60 degrees, well, let's go 30 degrees. The cosine of 30 degrees, and they got it in the book there, is the square root of 3 over 2. The cosine of 45 degrees is the square root of 2 over 2. And what am I doing? I'm doing this backwards. This one's 1/2, square root of 2 over 2, and the square root of 3 over 2. Now remember that these are cofunctions of each other, right? What are these to each other? Complements. So the cofunction of the complement has got to be the same, right? And the cofunction of the complement's got to be the same. And then these are the same. Square root of 2 over 2. And these are just standard, these 30, 45, and 60 are standard angles. And these are going to be these are the ratios of what? The sine is the ratio of what? The opposite side to the hypotenuse. And that's what these represent for these angles. So if you have a 60-degree angle, this is going to be the ratio of the opposite side to the hypotenuse. This is going to be the ratio of the adjacent side to the hypotenuse for a 60-degree angle. Now, these things do not change. So what I'm going to tell you, because everything is going to be based upon this. And this is the thing that you have to remember. If you go 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90. And if you do sine of the angle, this will start out, the sine of 0 is 0. The sine of 30 degrees was 1/2. This was the square root of 2 over 2. This is the square root of 3 over 2. And this is 1. Remember, the sign goes from -1 to +1. Well, it's actually, because it's a right triangle, we're going from here to here. So the cosine, and we don't use in right triangle trig, we don't use this and we don't use that, but in actuality, this is the way it goes. So the cosine, these are just going to go the other way around. The cosine is going to go 0, 1/2. Do you see what this is doing? It's just, this thing is turned upside down, coming down. Square root of 2 over 2. Square root of 3 over 2. And this is 1. Now, if you wanted to figure out the tangent, what would you do? You'd go sine over cosine. So all you got to do is learn this. So what is it? What is tangent at 90 degrees? No, sine over cosine. 1 divided by 0 is what? Undefined. And then this is going to be sine over cosine. So that's the square root of 3, isn't it? Square root of 3 over 2, and then 1/2 in the denominator, you invert and multiply. And this is 1, right? They're the same value, sine over cosine. And this is going to be technically 1 over the square root of 3, isn't it? This is in the denominator, that's in the numerator. You invert the denominator, multiply. You get 1 over the square root of 3, but do you leave it that way? You rationalize, right? So what you're going to see square root of 3 over 3. And then this is 0, right? Because you got sine over cosine. 0 over 1, that's 0. And then what's the relationship for cotangent? It's either cosine over sine, or else it's 1 over tangent. And then what's the relationship for secant? 1 over cosine, right? What's the relationship for cosecant? 1 over sine. So if you learn this, you got everything else figured out, right? And then the identity, see if you go sine squared 60 degrees plus cosine squared 60 degrees. Remember that sine squared plus cosine squared is got to equal 1. So that better be true, right? So the sine is the square root of 3 over 2. And we square it. The cosine is 1/2. And we square it. And it better come out to be 1, right? This is going to be what? 3 over 4 plus 1 over 4. And it's true. 1 is equal to 1. So your identities all, I mean, it's just, all those identities just work with, and these are the special angles. And we're going to be using these special angles. And what I'm suggesting, that right there, that you memorize that part, right? This much of it, I would really suggest that much stuff. You know it by heart. Because everything from here on out, those special angles, we'll be dealing with them. We'll be talking about them. And that's why they spend time with special angles. And then they're showing you what I just talked about on page 54 at the bottom of the page. And I'm gonna say it once more. These trigonometric relationships are saying that any triangle, this is the significant thing, and probably you have understood it, but I'm gonna if you have a right triangle, and if this particular angle right down here is 30 degrees, Now, it does not make any difference whether you talk about the right triangle that's here, or the right triangle that's here, or the right triangle here, or that big right triangle. If I write this as this long one right here, from here to here, is A. If the distance from here to here is A1, if the distance from here to here is A2, and the distance from here to here is A3. If the distance from here to here is C, the distance from here to here is C1, distance from here to there is C2, and the distance from here to there is C3. The ratios of if I do the sine of 30 degrees, it's going to be opposite. I better do cosine because I've got cosine set up. I do the cosine of 30 degrees. We said cosine of 30 was what? Square root of 3 over 2? And that's going to be the same thing as if you take the big thing and if you go A over C of the big triangle, or if you go A1 over C1, or if you go A2 over C2, or A3 over C3. Any one of those triangles, the ratio of the adjacent side to the hypotenuse is the same. It's the square root of 3 over 2. Does that make sense? That's what it's telling you. So what you can do is you can take your trigonometric functions and you can say, okay, in this problem, I can know this angle and I can measure this side. Now, which trig relationship gives me whatever side I want to calculate? And you can, so if you know an angle, if you're going I don't know, if you're going across the river and you got a river that's going like here, and if you can somehow take a point over here someplace, and if you can set up down here far enough and then rotate an angle so far out, go out here a certain distance and then rotate an angle back, you have the ability to know how far the thing is across here, right? See, if you set up your instrument here, shoot across here and run, and run an angle that's here that is actually 90 degrees. Establish yourself a line out here, and that this, from here to here, that this is a 90-degree angle. Then measure out here whatever distance that you want, establish the distance, set your instrument up, and then measure this angle back. Now you have the ability to be able to figure out how far it's crossed there, don't you? What relationship would you use? You have this side, you want to calculate that. You do the tangent relationship with that angle right there. And it's going to be a fixed ratio. And then you, opposite over hypotenuse, you know this side, you put that in, you put this as x, and is equal to the tangent of that angle, and you can figure it out. So with knowing trigonometry, those relationship stays the same, then you can do some calculations and do some measurement. They have some examples where you can, if you know how far, there's one example in the book that you're gonna have to be given. You know how far it is from here to the moon, and you can tell how big the diameter of the moon is by measuring the deflection, from one side of the moon to the other. Then you know the distance. Then you can calculate how big the diameter of the moon is by using right triangle trigonometry. It's going to be a problem. It's going to be a little bit more than that, but it's going to be a problem that you're going to have to figure out. Okay, so we're gonna look at the problems on 2.1. I probably spent more time than I ought to try to kind of explain to you what the relationship between the last chapter and this chapter is. A couple of people came in late, so. Okay. Okay, did you get the hair? Okay. All right, well, you gotta get that up.
Okay, is there homework from last week?
I think there was just that one homework. Did you go turn that in?
Yeah,
Turn that homework in. I'm sorry. Remember, you got the homework, turn it in.
That's from the very first week.
Okay.
Because I was in the hospital all last week.
Okay.
And then I
Did
got-
you get your test? Okay, there's a couple people I'm taking a test, so don't let him know what's going on.
The homework?
Yeah,
Is Monday gonna be okay for that then?
sure.
Last week and this week, tell us your old days.
Okay, right here.
Yeah.
I have good
Yep. All right,
How are you doing in the class there?
okay, now,
We lost and Friday on Monday.
Priorities.
I know,
Figure it
but
out.
I'm just not getting it, you know what I mean? I know it's so simple, I don't know how I can't do it, but there's just overlooked.
Just try to play with it.
okay,
I think it's on.
here's Dana, and then, what can we do?
Order here.
Or,
Yeah.
okay. I got you. James, wasn't it?
So there's only been one, this is now the second time it had been.
Yeah.
You're still recording, by the way.
Oh.
Thank you.
I just looked up there and saw it said
Chapter